So what I've got here on the bench then is an old HP Spectrum Analyser. It's the 8559. I'm not sure if this is an A or a B. Now I have got one of these. I don't use it anymore on a daily basis. In fact, I just keep it as a spare. I don't even keep it on the bench anymore. And in its day it was an excellent Spectrum Analyser, and if you can get one cheap enough, it's still a useful Spectrum Analyser today. But I picked this up last year at a ham fair, which is the very first ham fair I went to, and you can really pick up some bargains at those places. I got told to go to one last year by somebody, and the prices there, when you compare to looking for things like this on eBay, you know, are much cheaper. I mean, I picked this up for £15. I got him down from £25, and you could probably find this in its current state on eBay asking for a couple of £100 easily. These go for you know, £200-300 and listed as not working. So I picked this up, as I say, pretty damn cheap for £15, and the reason is because there's a lot of useful parts on this that we can use here in the lab. So I thought it'd be a good video, you know, a bit of a teardown. I can show you how this was constructed, because in its day it was really a work of art trying to get it all into this small form factor. And I'll go through some of the parts that I'm going to salvage off this, and also tell you why, you know, if you're buying one of these today, be really careful. Buy it if you can get it at a cheap price, but these are really at the end of their useful life now, and that's not due in part to the components and the electronics that are used in this. It's more due to the plastics that are used in this. It's degrading now, but I'll show you that as we go through. So it's not going to be a total teardown. I'm just going to switch the camera on when I get it to a certain part, and you know, there's something interesting to look at. So just taking a look around this then, this is what is known as a plug-in. There's no screen attached to this at all. It's designed to plug into a mainframe that has the screen on there, and there's various different mainframes that HP made over the years, but you can see here that they pack a great deal of stuff in to this small form factor, and you can't use this without a mainframe. This is where it all connects up to inside the mainframe, and it draws its power from there as well. But basically it's in this rectangle shape here, and it is not a great deal to see from the outside because it's packed in so tightly. So what I'm going to do is remove the sides and other bits and pieces, and then we can take a closer look at the inside. So we're going to start here, and one of the main pieces from here that I definitely do want to salvage is this mechanical attenuator here, because this Spectrum Analyser goes all the way up to 21 gigahertz. So that mechanical attenuator down there is rated from 0 right up to 21 gigahertz, sorry. So that's going to be a really useful piece of equipment here in the lab, and you can Google these attenuators on eBay. People remove them from things like this, and you can pay well over £100 for one of those on eBay on its own. They really do ask a lot of money for something like that, but it's going to be a really useful part, and I'm hoping we're going to get a few mixes and other bits and pieces, because one of my goals, I've been saving parts for quite some time now, is I want to build my own tracking generator for my Spectrum Analyser, and I think by the time I tear this down and salvage the parts from this, I've definitely got enough parts then to actually do that little project that I've had on the back burner for a while. So I'll have to pull my finger out and get that done soon as well. So I'm just removing the sides here, and I've got this first side off, and I just wanted to show you that the sides aren't just a box for all of this to fit into. They're an integral part of the design. They actually hold everything together. So now that I've got this first side off, you can see how loose everything is now, and you've got to remember this was designed around 1980, the late 1970s, and we never had computer design software back then. This was all designed by somebody using a ruler and a pencil, and they would have to talk to say the electrical engineers and different people from the different disciplines to get all this together into a package and actually work. And when you think of it like that, it really is, you know, a beautiful piece of design to get everything to fit in there and you know, and work. And the structure itself being held together by the sides really does make you appreciate how much time and effort would have gone into something like this, especially when you didn't have computers to help you put all this together like you do today. And even this is not just a runner to keep it straight as you plug it in to the mainframe, it's also the backbone of the entire construction to give it strength so it doesn't twist. And I remember when I was at school, I was taking my O-levels in the mid-1980s, and I took technical drawing at school, and I got a little bit disillusioned in the final year, because by then the computers had really started to come in. You got the BBC Micro and computers like that, and CAD design was really taking off, and I saw technical drawing as a dead end. And I was a little bit disillusioned putting all my time into learning that. But even today, I still prefer, when I'm designing something, to design it on pencil and paper, and then I put it into a CAD design. It's just something you know, artistic about designing it that way. And I know I'm wasting a bit of time doing it on pencil and paper first, but as I've got older, I do appreciate it a lot more. So you can see now how the case just held everything together. You've got this front end that's quite loose, it's just held on there with the wires, etc. And then you've got this second piece to the spectrum analyzer where most of the RF is going on in this enclosed area here. There was quite a few screws missing as well, so somebody's had this apart previously. And this warranty sticker here is put on at the factory, and there shouldn't be any real reason to adjust this screw here or go in here for any reason. You can really knock the calibration to pieces by doing that, so it's definitely been interfered with before in its life. So I've got the spectrum analyzer in two halves now. It was connected mainly by these two ribbon cables here and here, and a couple of other small connectors. I only had to cut these 3 wires, so they're the only wires I had to cut. Everything else easily you can remove the 2 halves, and it really is 2 halves, because what we've got going on here is we've got a mixer here, and I'm not sure whether that's a attenuator or a shocky diode, and we've got the mechanical attenuator here, and what it's doing, it's down converting the signal, you know, because this goes up to 21 gigahertz, but it won't feed 21 gigahertz into this part of the spectrum analyzer that analyzes the signal and displays it on the display screen. What it will do is down convert it into a more manageable lower frequency. So you've got this little mixer here, and then you've got this big mixer arrangement here on this side, and that's what it will be doing. It will be taking a gigahertz signal, down converting it into a more manageable megahertz signal, and then displaying that on the display screen. So it's not truly measuring at say 21 gigahertz. What it's doing is down converting that and then displaying that on the screen, and that's a relatively common way of you know, getting the spectrum analyzer to go up into the gigahertz region, especially from the 1980s. So we've definitely got some usable parts here. As I say, I'm really interested in this mechanical attenuator here, and you can see here the clockwork arrangement to adjust that mechanical attenuator, and everything on this front end in this area here, it's all really clockworking gears, and it's these that will fail over time. It's the plastics that rot and degrade and become extremely brittle, and that's what tends to fail on these, rather the electronics themselves. So what I'm going to do is try and disassemble all this, because we've got some really nice parts here. I mean, we'll probably be able to use that mixer there. I'm not sure whether that's a shocky diode or not. We'll see when we get that out. And we've got some kind of oscillator here, so we can definitely you know, probably use the majority of those parts, but we'll take a closer look at all the clockwork front end here with the knobs and hopefully I can show you how brittle this plastic is. It's something to really watch out for, especially if you're going to purchase a spectrum analyzer from this kind of vintage. So here's the parts that I've managed to salvage so far. So before we carry on, I thought we'd take a quick look at these. This is a little 3dB attenuator. I did originally think it was a shocky diode inline there, but it's not. It's a little 3D attenuator. It goes from DC all the way up to 21 gigahertz. Now there's a few sellers selling this on eBay, all from America. I mean, all of these parts seem to show up from American eBay, and he's asking $30 for this. The seller also wants $70 to ship it to the UK, but make of that what you will. And there's a few other sellers selling these as well for around the same price, $32 kind of price, so that'll come in handy. It's a nice little attenuator, especially with the range that it works over. Now we've got this little mixer here, and again there's a few sellers over in the US selling these for around $40, and I want to do a few experiments with this to test it out, because I think this will come in really handy with my tracking generator that I want to build. So I'm pretty pleased with this. Again, people asking around $40 just for this. Now this is the part that I really wanted out of it. It's a attenuator. It's a mechanical adjustable attenuator up to 70 dB, and it works from DC all the way up to 21 gigahertz. And there's a few sellers on eBay asking anywhere from $90 to $100. There's one guy selling one for $70, but it is a spares or repairs item. That one is not guaranteeing that it works. So around $100 is what they're asking for this on eBay in America, and as I'd say, I'll make a plenty of use out of this, because it works on that huge range from DC up to 21 gigahertz. And I'm going to fit some kind of knob on the end of this, because when you turn it, it does click, so you know roughly where it's clicking into for the attenuation from 0 up to 70 dB. But I think I might put some kind of a scale on here as well, just to give me an idea where it's on, and you know, that's a pretty handy thing to have. And of course we've got some plumbing here, and last year I needed one of these, and I fabricated one myself. Then somebody sent me one, and now I've got a spare one of those. So that's the output of the spectrum analyzer to the end connector on the front there. I've got this nice little coupler here, this SMA coupler, and it's a good quality one. I mean, I've got quite a few of these, but mine aren't up to the same kind of quality as this one, so that will come in handy. And I've also got this oscillator here that works from 2.95 gigahertz up to 6.05 gigahertz, so possibly incorporate that into some kind of project, and I'll probably do some experiments with this as well, and you know, find out how to wire this up. It can come in pretty handy. And again, there's sellers in America selling these for around $100. Somebody's selling one as low as $30 though, but he won't ship to the UK. So again, a nice little haul so far. All these little components that I will definitely make use of. So as you can see here, I've taken the front selection switches apart, and this is what highlights why something like this has come to the end of its life. And as I said, it's not normally down to faulty electronics, it's these things here. Now these are the selector switches, and they have these metal combs on here that make contact with these here. Now this is very much like a multimeter, you know, with the dial in the middle there. But what happens with these is the plastic rots, and there's a couple of little plastic rivets there that's riveted to the plastic here of the cog around here, and you can see that one has broken off and it's been lost, and it's not you know, inside the spectrum analyzer. It's been lost and fell off somewhere else, and that is what breaks, and then obviously the entire spectrum analyzer is faulty then, because you can't select in the range of what these combs were touching on. So you know, they're like a sprung steel. But what's really interesting about this one is sometime in its life somebody's had a go at repairing this, and instead of using the plastic rivets here, they've drilled in and screwed this screw down on here, and they've made a comb themselves. It looks like it's been made out of some kind of tin, but because it's not sprung steel, it's collapsed on itself. And although initially when they repaired this, it probably worked fine for a while, but just the act of selecting that switch would have caused them to fail, because they can't spring back like the sprung steel ones can. They're just flat because they're made out of tin. So that's why they're at the end of the life, because this plastic is now rotting and becoming extremely brittle. Now these tracks here can be cleaned, and I've got my spectrum analyzer that I use on a daily basis. It's a little bit newer than this one, but again, you know, I've got to be careful and keep my eye on it, and I'll probably have to do some repairs in the future, no doubt. But you can spray deoxit on this to clean the tracks and the pads on here, and deoxit is really good for cleaning. It's expensive. A tin can cost you around £25, but it really is good stuff. But I've read on a few forums to use it sparingly. I mean, you don't need a great deal of deoxit, because to use it sparingly, because it will add to the plastic and cause rot on the plastic, and you know, make that degrading happen a lot quicker. I don't know if that's true or not, but that's what a few people have said. It can just add to the decomposition of the plastic, making it more fragile and then causing it to break. But deoxit works really well at cleaning these tracks off here, because taking one of these apart and putting it back together again is extremely difficult. You almost need to be a watchmaker with all these cogs and gears, putting them back together and making it work again when you've stripped it down. That's why a lot of these come up for spares and repairs on eBay, because people have bought them, tried to fix them, and then not put them back together properly, and then you know, put them on eBay as spares or repairs. So you've got to be really careful buying something as old as this, because 9 times out of 10 somebody has had the lid off this and you know, done some kind of repair or something like that in its lifetime. You don't expect something like this to you know, be functioning without having some kind of maintenance somewhere along in its life. But certainly all these little things and bits and pieces here I will keep. I'll probably purchase a box specially to keep all these different parts in, you know, to fix my own spectrum analyzers. Hopefully, touch wood, I'll still get a few more years out of them. But these little things like this are definitely worth keeping. These little spring selection arms here, you know, because making one yourself is extremely difficult, and it does need to be made out of some kind of sprung steel, but manufacturing something like that is quite difficult to do at home. So finally we're just left with the tuning and mixing module. I mean, it's a pretty hefty bit of kit here. It's milled in 2 pieces of aluminium, and there's different sections in this that do different things. Obviously you've got the tuning section, and then you've got mixing sections that send the different signals off to the rest of the spectrum analyzer. And I don't think there's anything I'll be able to utilize this for, but I'll keep it just in case you know, I need a spare in the future, or find another spectrum analyzer and I decide I want to spend an afternoon trying to repair it, as long as I find one cheap. But for now I'll just put it in my spares box. So we're just left with the rest of the spectrum analyzer then. I mean, this at the back here, this is the power distribution board, and I'll keep this as spares, because as I said, a lot of these components are getting quite difficult to get hold of now. But when I'm storing something like this, I'll leave everything on the board. I don't go to the trouble of desoldering everything and then categorizing it. You know, there's just not enough time to do that. But I'll just label this up and then put it in my parts box. And same with all these boards here at the front. They are just standard electronics boards. I just bent that. But you know, little things like these heat sinks here that go around the transistors, really nice thing to have here in the lab. These resistors can be used in other projects, so definitely all of this will come in handy somewhere down the line. But as I said, a lot of these transistors and things now were just spun for HP, and they're getting really difficult to get hold of now. So finally then we're on to the RF section. You can tell this is the RF section of the spectrum analyzer, because we've got this aluminium enclosure, and it all seems to be sectioned off here at the top, and we can kind of guess with some of the labeling on the top here as well. But although this spectrum analyzer goes up to 21 gigahertz, as I said previously, it gets down converted in the tuning and mixer section of the spectrum analyzer into a more manageable frequency, because this isn't shielded enough to deal with gigahertz frequencies. Once you start getting into a gigahertz, it starts to get extremely leaky. So all this, although this section looks to be shielded here, it's not shielded good enough to deal with you know, frequencies a gigahertz and above. But it should still be quite interesting in here. I've just got quite a lot of screws to remove so we can take a look inside. So I've just noticed this very strange PCB on the top here. It's got two wires going to it, and they come from the back here, the connection that connects into the mainframe, and it almost looks like some kind of antenna, but it's just got two wires going to it. It's not coax or anything like that. I have no idea what that is. I mean, if anybody does know, please let us know in the comments. I mean, what is the purpose of this? I can't see the point of having a antenna on the inside there, and also we're being connected up with electrical wire. I've got no idea, unless it's just some kind of earthing thing, some kind of earthing filter for the you know, the DC that's powering this. I just don't know. So this is the first board then, and it's got on the top 321 megahertz going in and 300 megahertz going out. So as I said previously, it down converts the signal and feeds it into this unit here, because there's just not enough shielding for a gigahertz frequency here, but there's still a lot of shielding here, and it is quite interesting the way it's constructed. Basically, these coils here that you can tune, they're very interesting. You can see that these will influence the frequency of these coils without actually touching them. That's quite interesting there. I'm not sure how they work precisely. Somebody may know exactly how these work, but they're obviously coiled in such a manner for a given frequency, and then you've got the tuners here that you know, interact with these coils, and then you know, you can tune that frequency in even more. But you've got a massive ground plane here that grounds into these connectors, sorry, down in here, and you've got the massive ground plane here, and it's plated in gold, I think. I don't think it's all gold, you know, ground plane. I think it's probably tin and then plated in gold, just so it doesn't corrode and then affect the frequency of this board. But you can see on the other side as well, you've got you know, all covered, plated in gold here, and again plated in gold here, and you've got some little fingers here to make sure it's grounded to the side of the case as well. But a lot of these components I'll keep this board just as it is. We've got a oscillator here, but it's quite an unknown. There's no markings on there whatsoever. It's almost like a ingot of silver, and then there's another oscillator over here. But as I said, lots of vintage components there that could come in handy sometime down the road. So here's a look at the second board, and again, just lots of RF components on here, and you can see by the top two holes here and here, somebody has had this out previously. Somebody's been in here and either fixed something or just you know, had a look around the spectrum analyzer, because they've been ripped up by those two holes. They've tried to pull it out with the two holes here, and they've just ripped them off. It's not me who's done that, but it all looks to be in place. There doesn't look anything that's blown out. I'm looking at these two components here, one here and one here. They look really nice. They look like some kind of helical resistor. I've never seen anything like that before. And this one here has got this piece of looks like copper or brass plate here at the bottom. I don't know if that's a ground plane for this or something like that. I just don't know, or just maybe some kind of shielding, because if we look at the first board on here, you've got these wings here in between these coils, and there again they look like brass, and they're probably shielding you know, in between each other, so they're not interfering with each other in any way. It's just really nice. But we've got this one here as well, so for some reason they needed to put one here Whether it is because of this, I don't know. I don't even know if they're called helical resistors, to be honest with you. It's just you know, looking at them here, that's what they look like to me. I've never seen a component like that before, but we've got lots of RF components, and here we've got these capacitors, and I needed one of those last week for that fix that I did on the sweep generator there, because well, I think it had blown anyway. When I tested it with the multimeter, it was showing that it was blown. So these will come in handy probably in future different things, and again, I'll just leave all components on the board and just remove them as I need them. But yeah, it's another board, and lots of worthwhile components there. And again, we've got gold plate in here to the ground plane. Flip it over on the other side, not a lot going on here, but again, you know, real classic early 1980s circuit board layout here. And again, gold plate to the fingers there as well. So this is board number 3, and this is the step gain board, and they didn't really want you taking this one out because it even had some extra nylon screws down the side here to hold it in place, so you couldn't just pull it out of the unit. And it's also got this big brass warning plate here telling you not to interfere with this, and basically what that's doing is covering the access slits in there at the top, so you can't access all these potentiometers here to interfere with the adjustments, because that'll be set at the factory, and really you need to be qualified to adjust those, and the appropriate test equipment to adjust them with. But there's not a great deal on the board apart from all these capacitors and resistors here, and all this array of potentiometers here that are used for adjustment. A few ICs and chips down here, and then you've got some transistors. But it certainly is a board that's worth keeping just in case. A lot of nice components on there again, and this gold finish to the ground plane and the fingers themselves. But as I said, these transistors always come in handy, and all the specialist RF vintage components that you just can't buy anymore. But it's certainly an interesting board, and I suppose a lot of technicians that would have worked for HP in some shape or form, as a contractor, outside contractor, or directly employed with them, they would have spent their entire career just being proficient in adjusting this sort of thing, really. That's be their entire job and their experience. But you definitely don't have to do that kind of thing anymore, really. Now you just run software updates and such just to make adjustments and service machines these days. So it's all gone a bit with technology now, but it's still interesting looking at these things. So here's the fourth board, and if you're looking at this and thinking that you're seeing things, you're not. It is identical to the second board that we took out. These are both filters, both identical boards with the helical resistors on here, if that's what you actually call them. So it's obviously processing the signal, it's being filtered, then it's going into this board here, which is the gain adjustment board, and then it's being filtered a second time. So just like the second board, exactly the same, exact same model numbers and everything else. So again, I'll just be keeping this as spares. And this is the final board, and it's certainly the most impressive of all the boards. I mean, look at that gold ground plane there. It's almost a work of art. You could frame this and put it on your wall. I certainly put it on the wall of my lab anyway. But it's just made up of transistors. We've got this long bank of transistors here, and then this long bank of capacitors, and then lots of resistors down here. So it's probably amplifying the signal and setting the amplitude of the signal as well. But on the back, there's not a great deal on the back, but from this side it really is a work of art. The couple of potentiometers there, 3 potentiometers to do some adjustments, but not a great deal else going on with this board. But it is so nice to look at. So just from this spectrum analyzer alone, then I've got a huge haul of spare parts that I can use to fix my own spectrum analyzer if something happens to that. I've also got a huge supply of vintage electronics, especially RF vintage electronics, as well as this little group here that I will be using, and even this on its own has already paid for the money that I spent on this spectrum analyzer. So all of this here, I will be using the mixers here, and this little attenuator will come in handy, as well as the variable attenuator here, and all this plumbing comes in handy for other things and other projects, because at the end of the day this is rated up to 21 gigahertz. And I've also got a nice quantity of screws here that I'll be keeping as well. These screws fit vintage HP and other vintage products because they're imperial as well and not metric. And I've also got a nice collection of little clockwork parts here, and especially these that have the little combs on here. These will really come in handy if one of mine breaks and I can't find the comb, because as you can see on this one here where somebody had a go at repairing it, it's very difficult to make one of these, especially when you're not using sprung steel, because they don't last very long, and that's what happens. Those wouldn't have even been making contact on the PCB anymore. So even these on their own, really nice to have. You don't see people selling these on eBay very often. So I hope you enjoyed that tear down then, and the salvage off parts. If you did, please give it a thumbs up as always. Any comments, drop them below. Comments are always welcome, and hopefully you'll join me on the next one.